A very good afternoon to you and yours, and my name is Itumeleng Banda, and today we're out at Midrand at the Saice House, where I'm about to attend a lecture that is based on the Eastern Basin Acid Mine Drainage Project, which is a short-term intervention plan that has been instructed by Mr. Devilliers and Mr. Brits. Now, this project is the response of civil engineers and technicians to environmental issues, as this project is actually on a mission to decrease the amount of acid within underground water systems. I'm excited to meet the people who are behind the significant project and find out from them what it took to put together such an amazing project. Without any further ado, let's go inside. At the Saice House, where we just had a presentation by Dr. Devilliers, who is from Nyeleti, who told us about the whole process of the acid mine drainage project. Now, he does join me now. Thank you so much for joining me.
Thank you.
From your presentation that you had, and just before I get into that, a very congratulations on the project that you did construct, and it is proven as to why you are the ones who won it.
Thank you very much.
So you did mention in your presentation that the basin drainage system that you've created does extract water from under the surface. Now, the problem is that this water does have salt. Are there any plans into extracting the salt from the water so that the water can be used?
Well, there's two phases. The first phase has actually been implemented. They call it the short-term intervention. That is to pump the water out, to increase the pH, remove heavy metals. Some of the salt's been removed, but it's such that you can now put it to river. There's some salts still to remove, and then there's a second phase, the long-term intervention, and the idea there is then to remove the salts and to get it to a state that you can reuse the water, even for potable water.
Now, you also mentioned in your presentation that this is indeed a short-term intervention, and as said, that there is a long-term intervention that is in place. Within this short-term intervention project that you've put together, what were the major challenges that you and your team actually faced when coming up with this concept and actually putting it down and actually having it happen?
Well, there's a number of challenges. Firstly, there's a short time period you had to do it. So construction, also design construction, there had to be a due diligence. So investigation in terms of water quality, quantity of water you have to pump out, a number of challenges in a short time. Also that you're working with something that's underground, you can't get there, you can't see it. So yes, a number of challenges. Also in terms of technology, pumps, special pumps, big sizes, so not normal what you use in industry.
And we do know as well that there's a sludge disposal that happens within this whole process of taking out the acid from underneath the water. Now, the problem is, and I think the question that everyone is asking is, what happens to the sludge? Where does it go? And do we as people get affected, or does our environment get affected?
Well, in Central Basin, the sludge is actually co-disposed with mine tailings. So the amount and the concentrations is really minute in terms of the disposal. So it's a good solution, a co-disposal. So in that sense, no effect compared to the normal disposal, all under control.
Well, thank you so much, Dr. Devilliers.
Thank you.
So there you have it. They do say that the sludge does not have an effect on us, and I guess the future is bright because the engineers are hard at work. We are now joined by Ntate Katiso Molapo, who is from Rinka, Africa. He is an entrepreneur as well as a civil engineer. Thank you so much for your time, sir.
Thank you for having me, giving me this opportunity to come and speak to you.
Now, I know that your company works with designing pipes and stuff that engineers use. when constructing such big projects. Now, what is one thing that stood out for you as Mr. Brits actually spoke about the equipment that they use within this project?
The thing that stood out for me mostly was the size or the magnitude of the kind of equipment that was used, and the fact that they had to import skills from Germany. I think he estimated the pumps to be about 18 meters, which is quite, and 1.2 meters diameter, which is quite massive. I would be more interested to know what was the most expensive component in that project. As you saw, the construction values were about 1.1 billion and 600 million for one of them. So yeah, it was quite the size of the stuff that they used that actually stood out for me.
And from the size, as you are interested in the size of the equipment that they used, will that actually open a door within your company to once again consider certain things that you could also contribute to such big projects?
Yes, because we're actually looking into manufacturing large diameter plastic pipes, and I believe because of the size, we can actually sell pipes into this kind of projects, especially for discharging the treated water into the rivers.
So there you have it. That was Ntate Katiso Molapo from Rinka, Africa. And he actually says that he did actually absorb a few things that he is actually going to use within his company to take part in such big projects within the future. I am now joined by another man who is part of this extraordinary, very successful project, and he goes by the name of Mr. Eric Brits, and he is a mechanical engineer. Thank you so much for your time, sir.
Thank you.
So you spoke about all the mechanical side of this whole project. I would like to ask from you, what are the challenges that you and the team faced when actually choosing which pumps that will be used for pumping out this water from underground?
Thank you for the question. One of the biggest challenges that we faced was that the pumps were originally specified for a pumping head of 330 meters from surface, but at the time when we started lowering the level of the AMD, the level was already at 90 meters below surface. We had to think about this a lot, and the pumps are equipped with variable speed drives, but you are very limited with the amount of head loss that you can create by lowering the pump speed due to motor cooling and some other factors. So we introduced some flow control valves in the system, which throttles the system. It gives more resistance. It's temporary, and that was the only thing we could really do to be able to use these pumps for a low head of 90 meters. By the time the head reaches 150 meters, the valve will be fully open and there will be no further throttling. Throttling is actually wasting energy because you are generating head by your pump, but you're destroying it again in the control valve. But being a temporary measure, that was the only thing we could really do.
So there you have it. Very short, very sweet, but very educational and informative. Thank you so much for watching from us at Engineering TV. It's good night.